Data distributions for numerical variables. Let's start with the case when we have only one numerical variable. First, we are going to look at data tables and dot plots. We are going to do this by looking at question 1. The table below shows the number of students attending an after-school homework program over a period of 2 weeks, that is 10 school days. In part A, we are asked to construct a dot plot to display the number of students attending the after-school homework program for the 10 days. First, we need to draw a number line. Then we are going to look at the minimum number of students, which in this case is 10, and the maximum number of students, which is 20. And then we plot every other number between 10 and 20 on the number line. Remember always that these numbers have to be equally spaced. The minimum number is 10 and there is only one day with 10 students in attendance, so we put a dot above 10. There are no days with 11 students in attendance, so there is no dot above that. 12 students in attendance there are during 1, 2, 3 days, so we have 3 dots above 12. There is one day with 13 students in attendance, so we have 1 dot above 13. Then there is one day with 14 students, so there is a dot above 14. The same, there is one day with 15 students in attendance, so there is 1 dot above 15. There are no days with 16 or 17 or 18 students, so there are no dots above those numbers. Then we have 2 days with 19 students in attendance, so we put 2 dots above 19, and 1 day with 20 students in attendance, so there is 1 dot above 20. And this is the dot plot for this set of data. Part B. What percentage of days, correct to the nearest percent, had at least 15 students attending the after-school homework program? At least 15 students, that means 15, 16, 17, 18, 19, or 20. There are 4 dots above all these numbers, which means there are 4 days. So we calculate the percentage using the number of days with number of students required divided by the total number of days. That is 4 over 10 times 100, which is 40%. In part C, we are asked to calculate the percentage of days that had more than 15 students attending the after-school homework program. More than 15 students means 16, 17, 18, 19, or 20. Now, there are 3 dots above these numbers, which means 3 days. So again, the number of days with number of students required divided by the total number of days, that is 3 divided by 10 times 100, which is 30%. In part D, what percentage of days, correct to the nearest percent, had less than 12 students attending the after-school homework program? Less than 12 students means 10 and 11. There is only 1 dot, which means 1 day. Again, we are going to use the same formula. So we have 1 divided by 10 times 100, which is 10%. In part E, for this set of data, calculate the mean. We know that the mean is the sum of all data divided by the total number of data. There is 1 dot above 10, which means we have a 10, 3 dots above 12, which means we have 3 times 12, 1 dot above 13, so plus 13, and we continue like this, plus 14, plus 15, plus 2 times 19, because there are 2 dots above 19, plus 20, all divided by 10 because there are 10 days. And that gives us a mean of 14.6. 2i. To calculate the mode of this set of data, just remember that the mode is the score that occurs most often, or the score with the highest frequency. If we look at the dot plot, there are 3 dots above 12, so the mode is 12. Then we are asked to determine the median of this set of data. Remember that the median is the score in the middle. In this case, the median is between the 5th and the 6th scores. So we calculate the median, which is 13 plus 14, all divided by 2. And that gives us a median of 13.5.